Okay, so we're going to go to day 4 and we're going to review solving systems of equations. So this is a review from Algebra 1. Starting with our warm-up here, we're just going to look at what the solution to the system of the equations are below. And really what we're looking for, if we look at A first, you can see the solution is going to be in 2 locations. Those are 0, 1 and -2, 3. -3. Whew, there we go. Okay, so for B, our solutions, again, where these 2 graphs intersect, okay, we have the points 0, 2 and 2, 0, which is out the other way. And last but not least, okay, the third one, again, we're looking for those points of intersection, and my solutions here are -1, -5, and 4, 0. Okay? Ultimately, when we're looking for the solution to the system of equations, whether it's graphically or algebraically, we're looking for where the intersection of the graphs will be. Okay, so the solution or solutions, because you see that there can be 2 of them, of any system of equations refers to where they intersect. All right, so if we move down here, we're going to take a look at using the calculator to find your solutions graphically. Okay, so as always, the first thing you want to do is make sure in your y equals you enter the first and second equation in y1 and y2. And these are our example ones. So if you have one, a calculator, if you're using one of mine, just go ahead and enter these into your calculator for y1 and y2. And then, of course, just to make sure, that your graphs do show up, you'll see the 2 graphs appear when you hit the graph button. Okay? Now, we want to find the solution. We want to find out where and what that coordinate point is graphically, and we want the calculator to do it. So if we flip over, okay, we're actually going to be at step number 5, where you're next going to hit second calc and number 5. So if you look here, and let's make this a little smaller, you're going to hit second, still a little big, second, and you're going to hit the trace button. So this button right here, and then this button right here. Okay, and you're actually going to select to find where they intersect. Okay, after that, the first thing it's going to ask you is, which one is your first curve? And you'll see there'll be a blinking dot on one of the first lines. That's your first curve. That's your first line. So you're going to go ahead and hit enter. Okay. After that, it will bring you to the next line with the next question. Second curve, meaning, right, the little dot will move and it'll say, okay, basically, is this your second curve? It is. That's your second line. So you're going to go ahead and hit enter. And then the last screen that pops up will ask you what your guess is. And that will be blinking generally around where that second dot or the second curve was. Okay. And this one doesn't matter. You're just going to hit enter, because ultimately it's going to give you the point of intersection regardless of where your guess is. Okay. So after you hit enter, you're going to see on the bottom, it's going to say where your intersection is. Okay, so for these 2 lines, the solution or the intersection is x comma y, so -3 comma -2. And it shows you right where they cross. That's going to be your intersection. That's going to be your solution. Okay, so if we do a couple examples, and you can kind of pause this as we go, and this way you can go at your own pace. The first thing we're going to do on the next one, if you look, this one is already set to y equals. So you can go ahead and enter that one in the calculator. This one is not. So what we want to do is solve for y so that we can plug it into the calculator appropriately. Okay. First thing we're going to do, bring the x over. So we're left with 3y equals negative x plus 6. And then last but not least, divide everything by 3 so that we're left with y equals, and then over here, there's technically a 1 in front of that x, so we can leave this as negative 1/3 x. And then over here, 6 divided by 3 is positive 2. So now we can plug in our second equation into the calculator, and we do the same steps, okay? So you're going to plug them into your y equals. You're going to go ahead and view the graph, and we're going to start the same way by going to second calculate, which is the trace button, okay? Right there and right there. And we're going to select number 5 because we want to see where they intersect, where the solutions or solution is. Again, it's going to ask the same thing. What's your first curve? And it's going to have the blinking dot. We hit enter. Next one, second curve, same thing, right? It's going to just move that little blinking dot to the next line. And then the last thing it's going to ask is, what's your guess? And the guess doesn't matter because it's going to give you that point of intersection anyway. So at the end, after you hit guess, it should give you the intersection or the solution. Now, of course, it's okay that it's a decimal. We're just going to see what they want us to give our answer to, which is to the nearest hundredth. Hundredth is 2 decimal places. So if we look here, my point of intersection or my solution is going to be 1.29 comma 1.57. Okay. Let's go ahead and take a look at the next one. These, luckily, are both in y equals, so go ahead and plug them into your graph. Again, you can pause the video while you plug it into the graph, view the graph, and then again, the same process happens, right? So we're going to do second calculate, and we're going to look for the intersection. It's going to do the same thing. What's your first guess or your first curve? What's your second guess or your second curve, right? That blinking dot should move each time to the first line and then the second line. And then last but not least, they want to know, okay, what's your guess? Doesn't matter. Hit enter. And again, it's going to give you your point of intersection. Okay, this is your solution down here, and it shows exactly where they cross. Okay, this one asks to the nearest tenth. They're already given to the nearest tenth. So my final answer here, right, negative 0.4 and negative 3.6. All right, so you're going to use these steps to find the intersection of any system of equations, including, if you look down below here, including quadratic linear systems. So it's not just going to be 2 lines like up here. It's actually going to be a quadratic or a parabola and then a line. So in this case, you might have to do these steps twice and a little bit of movement for your lines or your curves. So if we look at these two again, these are in y equals. So go ahead and plug those into your y equals, view the graph, and let's start the same way, right? So you are still going to do second trace or calculate, right? And we're going to look to see where they intersect. So because my graph has 2 points of intersection, which you can clearly see. We need to start with one of them. So let's start here, okay? When it asks for the first curve or the first line, you just want to make sure that it's around this point of intersection. After, same thing, you're going to hit enter, and it's going to ask for the second curve, right? The questions don't change. My second curve, that little point should jump to the second line, but again, it should be around that initial point of intersection. Hit enter as long as it's around that point. And then just like before, it's going to ask for a guess. And again, that guess should be around where they intersect, right? Because that's the point that we're trying to focus on. So then I end up with the point of intersection, or my first solution, as 0, -2. Okay. Now, I will have to do this again for my second point, right? I mean, this has 2 solutions. So you have to do the same steps a second time. The only difference, so I'm going to go back to my second calculate, right? Second trace, and find that intersection. Except this time, when it asks for the first curve down here, I want to shift my points down, right, to where they intersect here. Okay, so you just try to get it as close to where they intersect. It ultimately won't matter because it'll give you the answer. And we go through the process again. So first curve, second curve, or second equation, right? That point is going to jump. Should still be around the same spot. And the guess does not matter. As long as you're around that same spot, the guess will give you the second point of intersection, which is -2, -8. Okay? So it gives you both points of intersection. As long as you do it twice, you get -2, -8, and 0, -2. Okay? Why don't you go ahead, we can pause the video here, and you can try B on your own, and then play the video back and check your answer. Okay, if we take a look at this graph, if you zoom in on here, you can see that this is only going to cross at one point, so you only have to do the point of intersection one time. So again, our first curve, our second curve, our guess, and then it will give you the point of intersection as this point here, -2, +4, because we don't need all those zeros. So the point of intersection here is -2, +4. All right. So this is graphically how to solve system of equations, viewing it, finding that point of intersection on the graph. If we flip to the next page, this again is a review from Algebra 1 of solving systems algebraically. Okay, there are 2 options to solving systems algebraically. We're going to look at both of them. The first one is using elimination. Okay, you're going to look to cancel or eliminate one of your variables by combining both equations. Okay, so you want them to have the same coefficient, the same letter, opposite signs, so that you can eliminate or cancel. So if we look at our system of equations below, I have my x's lined up, my y's lined up, and my constants. So if you look at the system, I see I have opposite signs and almost, right, the same coefficient. The only thing I would need to do here is multiply by 2, right? So if I multiply by 2 here, I want to make sure I multiply by 2 in the whole equation, because we need to keep our equation balanced. So I'm rewriting down here both equations, okay, and I'm going to multiply by 2 by distributing that 2 to everything. That first equation is going to stay the same, and after I multiply by 2, we get 6x minus 2y equals negative 8. When we combine our equations together, you can see right here, this was the goal, positive 2y and negative 2y will be eliminated, okay? The rest we can combine and solve. So this is going to give me 8x equals 24. And then by dividing both sides by 8, we get our x value as 3. In order to get our y value, so once I know x, I can substitute x for one of these x's or one of the original x's and solve for y, okay? If we substitute the 3, I substituted it into the first one here, okay? This is my x, and we substituted in 3. We're going to solve from here. 2 times 3 gives us 6, plus 2y equals 16. We're going to move the 6 over by subtracting. We're left with 2y equals 10. And then last but not least, divide both sides by 2, and my y is 5. So my solution, right, if I were to graph these, where they would cross would be 3, 5, okay? But instead of doing it graphically, we're doing it algebraically and working through the problem by hand, okay? Let's try another one down here, which you can see down here, they're not lined up with the equal sign, and the y's and the x's all one under the other. So I am going to move, right, that 2x over so that the x's and y's are on the same side. If we move the 2x over, this is going to give me y minus 2x equals negative 2. And this one can stay the way it is because I have my y's, my x's, and my constants all lined up, okay? So I'm going to rewrite this down here. And once they're all lined up, you can see, right, that all I need to do is multiply this y by a negative 3. But because I'm changing and multiplying by negative 3 here, I have to make sure that I do it to every part in that equation, okay? That first equation is going to remain the same. And then the bottom equation, after I distribute, we get negative 3y plus 6x equals positive 6, right? Because the negative times the negative. And then, of course, right, here's my elimination piece. This is the part, right, I want to get rid of. And I'm going to go through and combine the rest. So this is going to be a positive 3x, and this is going to be a positive 15. Last but not least, right, divide by 3 to get x is 5. You can choose which equation to substitute that x in. Okay, you can substitute here, you can substitute here, you can substitute here, and then solve for y. So I believe, yep, we substituted into this first equation, and we put the 5 in for x, and then we simplify. 2 times 5 is 10. 10 minus 2 is 8. So our solution here as a coordinate point would be 5, 8. All right? So that is your method by elimination. Okay? If at any time you need to go back, go through the steps that we just did, feel free to go back and check. Our next option for solving systems algebraically, again, which comes from Algebra 1, is by substitution. So substitution, you're going to look to isolate one of the variables, right? When we isolate it, we want to get one variable by itself. So that can be the x or the y, and then substitute appropriately into the next equation. So if we look here, we have a couple of options. And it's really going to be based on what you feel comfortable, solving for. I like to try to pick the ones that have, the smallest coefficients, things that I can move around easily. And if I look here, it's very easy to solve for y by moving the x over to the other side. So this is going to become y equals x plus 3. So by using, or substituting, rather, solving for y, I've now got the y alone, and I can take this equation and substitute into my second equation for y. So I can replace the y in the second equation with what I found by solving in my second equation. So what that's going to look like here, I'm going to replace my y in the second equation. And so instead of y, I'm going to plug in my x plus 3. This is what I solved, right, for y. And once we replace it, all my variables are the same. They're all x's. So I can use, right, my simplifying my expressions to get my x value. So here it's we're just adding. There's really nothing to distribute. Nothing is going to change. So I can just combine, right, the x and the 2x. And that's going to give us 3x plus 3 equals 5. From here, we're going to minus 3 on both sides. That leaves us with 3x equals 2. And then last but not least, divide both sides by 3. And we get x equals 2/3, right? We're not going to get a decimal. We're going to leave it as a simplified fraction. Okay. Now, same thing that we did for elimination. Once you have one variable, you can substitute it into any of the equations to solve. I'm going to actually substitute that x, which I get here, into my x that I solved over here. Okay, so y equals, instead of x plus 3, we're going to go ahead and substitute, right, the 2/3. And 2/3 plus 3, we all have the ability to do this on the calculator, is going to give us, well, you can do 9/3, or you can just plug it in. It's going to give you 11/3. Okay, so the point of intersection, the system to the equation, the solution, rather, to the system of equations is 2/3, 11/3. All right, it doesn't matter if you get a fraction or a whole number. The goal is the same. Okay, this is where those points are going to intersect, or the two lines are going to intersect. Okay, so I want you to take a minute, try number 2, and then come back and check your work. Okay, so one of the first things I did was identify that I wanted to solve for y. I wanted to get this y by itself. The easiest way to do that was to subtract the x over. By subtracting the x over, I get y equals negative x plus 1. And I can now substitute that y into my second equation below. So, substituting the y for negative x plus 1, I get 3x minus, instead of the y, again, I'm substituting negative x plus 1, and then equals 3. From here, we can distribute, okay? And then when we distribute, we get a positive x and a negative 1. You can combine like terms here. So we get 4x minus 1. Add the 1. 4x equals 4. And then last but not least, divide, and we get x equals 1. Substitute that 1 into one of the original equations, or the one that you solved. I substituted it into the x over here. So negative 1 plus 1 is 0, and the solution is 1, 0. Okay, we'll finish up talking about example 5 in class, but really, if you need to go back over the lesson, check that you understand how we got all these solutions, either through substitution or elimination, or if it helps, go back over the graphical steps to find those points of intersection. Okay? And we will discuss and go over them in class.